Subnetting is the process of dividing a larger network into smaller networks or subnets. Each subnet is connected to a larger network and has a unique subnet address. Let's take a look at an example of how subnetting can be used. Let's connect a private network to the internet. We have a total of 6,000 computers on the network. The ISP assigns us a Class B address of 190.60.0.0. The default subnet mask is 255.255.0.0. With this network address, we can create one large network that has over 65,000 hosts on the network. But the networking architecture may limit the number of hosts that can be on a single subnet. For example, Ethernet has a limitation of 1,024 hosts on a single subnet. Because we're using Ethernet, we'll need at least 6 subnets. Using subnets also conserves IP addresses. We have 6,000 hosts, but we're wasting approximately 59,000 addresses. That's 59,000 addresses that can't be used by any other host. We're not using them, but we're paying for them. To avoid wasting addresses, we use subnets to break this larger network address down into smaller subnet addresses. To create subnets, modify the default subnet mask. In this example, we have a Class B address of 190.60.0.0. Using the default subnet mask, we have a single network with over 65,000 hosts. To create additional subnets, use a custom subnet mask that is larger than the default. For example, we can use a mask of 255.255.255.0 to create additional subnets by modifying the number in the third octet. The subnet address occupies the first 3 octets in the address. The mask value applied to the network means that we can have the following subnets: 190.60.0.0, 190.60.1.0, 190.60.2.0, all the way to 190.60.255.0. This subnet mask allows a maximum of 254 hosts on each subnet. For instance, on subnet 190.60.2.0, we can have hosts 190.60.2.1 up to 190.60.2.254. With 6,000 hosts on our private network, we need approximately 24 subnets, each subnet having about 250 hosts. In this example, we'll use subnets starting at 0 up to 24 in this third octet. We don't need the entire address range. Now we can go back to the ISP and tell them that we don't need anything above 25. Those will be returned and reassigned to other organizations. Let's look at another example. Let's assume that we've been assigned an IP address of 190.0.0.0. The default subnet mask in this case is 255.255.0.0 because this is a Class B address. If we want to subnet this address, we could use a custom mask of 255.255.255.0. What would the possible subnet addresses be? The subnet addresses are identified by the first 3 octets when we're using this custom mask. But because we started with this original address with a default mask, we also cannot modify anything to the left. We're restricted to modifying only the third octet because we still have to fit within this original network address. Our possible subnet addresses start at 190.0.1.0 and continue on from there, modifying only the third octet. When creating subnets, you can only modify the mask bits that come after the original mask. Do not modify the original mask. In this example, you can't change the 0 in the second octet because of the mask. For example, using 190.1.0.0 is not allowed. If you do, you've modified the network portion of the address that was assigned. In each of the examples we have looked at so far, we've modified the default subnet mask by adding an entire octet. For example, we've added 255 to the third octet. It is also possible to create subnet masks that do not use a full octet. To do this, you have to look at the subnet mask in binary notation. The subnet mask is a series of all ones followed by a series of all zeros. Whenever you have a 255 in an octet in the mask, you actually have 8 ones within that octet. In the previous examples, we set one of the octets to 255 to create additional subnets, which translates into a series of 8 binary ones within the subnet mask. We can use only part of an octet for the subnet mask. This is called a custom subnet. In this case, only some of the leading bits in the octet are set to 1. The rest are set to 0 and are used for host addresses. For example, we could have a subnet mask that looks like this. In this octet, we have 5 ones followed by 3 zeros. You must have a series of all ones followed by a series of all zeros in the subnet mask. You cannot use a number like this. This is an invalid subnet mask because there is a 0 in this position. The subnet mask must be a series of all ones up to the network portion of the address. The decimal values that can occupy an octet within the subnet mask are limited. You will only see the following values within an octet of a subnet mask. You can see a 0, 128, 192, 224, 240, 248, 252, 254, or 255. To understand why this is the case, convert each of these numbers into a binary number. The subnet mask must have ones in the left-hand portion, so the possibilities are a series of 8 zeros, the decimal equivalent of 0, a 1 followed by 7 zeros, the decimal equivalent of 128, 2 ones followed by 6 zeros, the decimal equivalent of 192, and so on until I get down to the end where I have 8 ones, which is the decimal equivalent of 255. We call an IP address a classable address if it uses the default subnet mask. An address is classless if it uses a custom variable length subnet mask. Classless IP addresses are created by modifying the length of the subnet mask. This is made possible by a feature called classless inter-domain routing, or CIDR. One feature within CIDR is something called variable length subnet mask, or VLSM. With VLSM, you simply modify the length of the subnet mask in order to create subnets. With classless inter-domain routing, you can represent the subnet mask in a kind of shorthand which identifies the mask without writing the full 4-octet number. In this example, we have an IP address of 10.1.2.0 that uses a custom mask of 255.255.255.0. Using the shorthand method, you can represent the mask by simply counting the number of bits with a value of 1 that are in the mask. Each octet is a series of 8 ones. To specify the mask, you can indicate the length of the subnet mask, which is defined as the number of 1 bits within the mask. Each octet has 8 ones. You have a mask of /24. You are using 24 bits in the subnet mask. If you were to take these last 4 bits and set them to 0, the subnet mask would be 8 plus 8 plus 4, which is 20. If only one octet is filled in the subnet mask, there are 8 bits, which corresponds to the default subnet mask for a Class A address. A default subnet mask for a Class B address fills 16 bits, while the default mask for a Class C address uses 24. If we're using classical addressing, we can assume the length of the subnet mask from the class. With VLSM, we can reallocate bits from the host portion of the address to the network portion to create a custom subnet mask and multiple subnets. For example, suppose your network is composed of 4 separate physical network segments connected by routers. This network uses the 10.0.0.0 private IP addressing scheme, so you want to divide the 10.0.0.0 network into 4 separate networks. By default, this network uses a Class A address. This means the first octet is used for the network address, while the last 3 octets are used for node addresses. However, we can create 4 additional networks, or subnets, by configuring the subnet mask to include the first 2 bits of the second octet and the network address to create additional networks. Instead of using the default Class A subnet mask of an octet of 1s followed by 3 octets of 0s, you would use a subnet mask of 1 octet of 1s, an octet with 2 1s and 6 zeros, then 2 octets of 0s. Using CIDR notation, we would specify a prefix of 10 to indicate we are using 10 bits for the subnet mask. The first 2 bits of the second octet are used for the subnet mask. There are 4 possible values for these 2 bits. 0, 0 in binary is equal to 0 in decimal, 0, 1 is equal to 64, 1, 0 is equal to 128, and 1, 1 is equal to 192. This will create 4 subnets. Network 10.0.0.0 has a host range of 10.0.0.1 through 10.63.255.254 and a broadcast address of 10.63.255.255. Network 10.64.0.0 has a host range of 10.64.0.1 through 10.127.255.254 and a broadcast address of 10.127.255.255. Network 10.128.0.0 has a host range of 10.128.0.1 through 10.191.255.254 and a broadcast address of 10.191.255.255. Network 10.192.0.0 has a host range of 10.192.0.1 through 10.255.255.254 and a broadcast address of 10.255.255.255. There are many subnet calculators available online that you can use to calculate these parameters for a given subnet and its mask length. Another concept that you need to be aware of is called supernetting. Supernetting takes multiple smaller network addresses and combines them into one larger subnet address. With supernetting, use a shorter mask to combine the subnet addresses into a larger address space. In this example, you've been assigned two Class C network addresses from my ISP. Using the default subnet mask of 24 bits, we are limited to about 250 hosts on each subnet. But what if you wanted to put 400 hosts on the same subnet? You can't actually do it because you don't have enough IP addresses to assign within this range. In this case, you can use supernetting. Instead of making the mask longer, you are making the mask shorter. By making the mask shorter, we have a network address that begins at 0, but also includes values up through 1 and 255. That's it for this lesson. In this lesson, we talked about subnetting. We talked about what subnetting is. We talked about using the default subnet mask for the various classes of IP addresses. We talked about using custom subnet masks, and we talked about using CIDR notation. Then we ended this lesson by talking about supernetting.